we're going to go ahead and take a look at lesson 10, which talks about repeating decimals. You know at this point that we can take any fraction and follow the rule, divide the numerator by the denominator to find its fraction. And so far they've been pretty nice. We've been looking at fractions like 3/4. Follow that rule of numerator by denominator. 3 divided by 4, plugging that into the calculator and getting 0.75. Or by doing the long way out, whoop, 7. This would be 28. Subtract 2, 0, bring that down. 5. Doing it like this. And it always works out nice and even. With a nice 0, you know you're done. But today in repeating decimals, repeating, you know that repeating means it just keeps going on and on and on and on and on, forever and ever, amen. Forever. That's what repeating means. Well, we're going to find a whole bunch of fractions that have a repeating value. It may be one number, it may be two numbers or more, but they repeat over and over and over again. So rather than just 0.75, we might see decimals that look like 0.75, 75, 75, 75. Or we might take a look at decimals that are 0.3333, and they keep going on forever and ever, amen. Our book does a nice job of showing us some examples. So here we can kind of see that 1/1 is a nice ending decimal. 1.0, 1 whole, 1/2, 0.5, 1/4, 0.25. Everything on the left-hand side here is nice, neat, clean decimals. Even 1/16 is 0.0625. But we look over to the right, and it's such a big column. Look how many 3's are here when we take 1 and divide it by 3. When we take 1 and divide it by 6. 1 divided by 7 is monstrous. It has 1, 2, 3, 4, 5, 6 repeating numbers. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. It just keeps repeating and repeating. And you notice at the end of all these columns, it has 3 dots. This is kind of like your favorite TV show. When it goes off the air after 30 minutes and it says, to be continued. The story's not done yet. The fact is these fractions like 1/19 or 1/15 are so small that they can never ever be cut in a way or show a value that is completely definite. In other words, there's no exact answer. It just keeps going and going and going. No matter how many times I try to cut it, 1/9 is going to be 0.111111 all the way through infinity. I can't ever pin it down and say it ends here. And that's why we call them repeating. We're going to take a look at today some activities where we have fractions. 4/5. And I'm going to show you exactly how we show repeating decimals, because it's important that we show that they repeat. If we don't show that they repeat, we show that they end. Repeating decimals never end. So when we get one of those on a calculator, we want to show that it's repeating. And I'm going to show you how. We're going to take the example 4/5. Get to the right screen. You know that 4/5 looks like this. You also know how to change this into a decimal. And we're kind of done doing the long division. I could prove this through long division, but I want you to know as long as you take the numerator and divide it by the denominator, top divide by bottom, you'll get that answer. So when I pull up the calculator, here's what I'm going to see. 4 divided by 5. 0.8. Nothing new, nothing nice there. Or not nice, I should say. 0.8. Let's go and find a nice non-repeating decimal. I'm going to take this problem here. 5/8. Let's try 5/8. 5/8. Do my whole communication. 5 divided by 8. Let's plug it into the calculator. Nope, that one was nice and neat too. Sometimes it doesn't always happen. I'm going to have to get tricky on you guys. Alright, let's do this problem. 3/11. If I take 3/11, 3 divided by 11. This one I know. 3 divided by 11. This isn't going to be pretty. Alright, so just because the calculator doesn't give me those 3 little dots, it goes on forever and ever. It repeats. So what I'm going to do is I'm going to write the 0.27. Go back to the calculator, and I'm going to first ask myself, what is it that's repeating? Is it one number or is it several numbers? And here I see it's 27, 27, 27, 27, 27. 27 keeps repeating. 27 keeps repeating. If that's the case, whenever numbers repeat, what I do is I put a bar over the top. This bar tells me that that 27 will repeat over and over and over again for eternity. I don't have to continue to write 27, 27, 27, dot, dot, dot. Don't do this. Don't go 0.27, dot, dot, dot. Nope. Not okay. One bar over just the numbers that repeat. Let's go back to that book and let's look at some examples here. Let's take that 1/7. 0.142857. Woofda, that's a big one. 142857. 142857. 142857.0. And rather than going through and trying to write those same numbers over and over and over and over and over again, the whole thing repeats. So I put a bar over all those numbers. I don't put a bar over the 0 because the 0 doesn't repeat, but just the 142857. 142857. And what this tells the reader of your math problem is hey, this number keeps going on and on and on. The bar above the top only goes above the numbers that are repeating. Let's go ahead and look back at our book. And let's take 1/3 as a good example. We know that 1/3 is 1 divided by 3. Take that calculator. And I get 0.33333333333. Generally speaking, the rule here is even though you might say, well, 333 is repeating, or 3,333 is repeating, you look at that first number, and as soon as that first number repeats itself, and that's the only number that repeats itself, you show your answer like this. 0.3 repeating. The 3 is the only number that repeats. Repeating numbers go on forever and ever and ever. It never stops. So the line above the bar again shows the reader of your math problem that, hey, this isn't just 3/10. This is a 3/10 that never stops. Okay? Thank you for watching. Thank you for watching. Thank you for watching. Thank you for watching. I keep repeating myself till it gets through. Stick in and let's get to work.